Okay, so another ladder problem here. It says below shows a non-uniform ladder AB resting at equilibrium against the top of a smooth vertical wall. The ladder touches the wall at the point C. The end A rests on rough horizontal ground. Coefficient of friction between the ladder and the ground is mu. Ladder makes an angle of 60 degrees with the horizontal. The mass of the ladder is 10 kilograms. AB, so the length of the ladder is 8. And then AC is 7. Draw a diagram showing all the external forces acting on the ladder. I'm just going to do them on here. I hope you're happy enough with that. So it is a rough ground, so that means we're going to have a friction going that way. There's a normal reaction going here. As ever, we have the weight of the ladder acting down, which is going to be 10G. Incidentally, that's not halfway along, because it's a non-uniform ladder. And this is a slightly tricky bit, which is a bit different than most examples. The reaction from the wall coming out here is this. It comes that way there because of the way it's sitting up against the ladder. So that's quite a wee tough bit and a new concept to grasp. So it's coming out at right angles in that case there. It says the reaction between the ladder and the wall at C is 39.2 newtons, so we can stick in a 39.2 there. And it then says by taking moments about A, find the distance of the centre of mass of the ladder from A. So we want to find this distance here, and I'm just going to call that X to help us work it out. So let's take moments in about our point A. So this is part 2 here. We're going to take moments about the point A. Let's show the examiner that we're doing that. And we're going for clockwise equals anti-clockwise. So if I'm putting my pin in here at A, this 10G is taking it clockwise and the N is taking it anti-clockwise. So the clockwise one, our distance is X multiplied by 10G, and let's get our angle here. We're effectively resolving it this way here. As I've always said, there are other ways. If you can work out that distance there, that's the perpendicular distance. But if we go X times 10G, so what's our angle? That is 60. That means that's 30. That means that's going to be 60. So it's 10G cos 60. Anti-clockwise one is a wee bit more straightforward. Our distance here is 7. And we're told that, so it's already going perpendicular, so it's going to be 7 times 39.2. If you put this into your calculator, you do 7 times 39.2, you divide by 10G cos 60, you will get a value of X equal to 5.6 meters. Part 3 then is find mu. So to find mu, I hope most people are aware, we're going to have to find R, and we're going to have to find FR. If we know those two, we can work out our mu. This one's nearly a bit backwards, I think, than most questions. Most times I would be resolving up and down, resolving left and right, and then taking the moments third. But let's take a wee look then. So resolving up, everything going up equals everything going down. We're going to have R plus, it's a wee bit tough, let's take a wee look. We need to resolve this N straight up this direction here. So let's see what angle we're going to have. If that's 60, then with a wee bit of tinkering around, we'll realize that that has to be 60 as well. So it's going to be R plus, let's see, 39.2 cos 60. So that's everything going up, and then everything going down is a nice straightforward one, is going to be 10G. Rearranging that, we're going to get R equals 78.4 newtons. Everything going left equals everything going right. So we're going to have, going this way here, we're going to have our friction, and then that equals everything going the other way. So let's go back up to our wee diagram here. Again, we're trying to resolve this in this direction here. What do we know? We know that's 60. So we would know that's 60. We're going perpendicular there, so we're not going to cross the 60, so it's going to be sine. So it's going to be 39.2 sine 60. Put that on your calculator and you get 33.9481. We know, of course, that friction equals mu r. Mu then is going to be friction over r. So we put those two values in and we get a value then of 0.433. That's the three significant figures.